Hi, my name is Parastu Khoshakhlaq. I'm a co-founder of Tympanogen.
My name is Elaine Horn-Raney, also a co-founder of Tympanogen.
We have developed a patent-pending gel patch to resolve a medical condition called tympanic membrane perforations, or holes in the eardrum. While working with ear, nose, and throat surgeons, or ENT surgeons, medical student Jesse noticed a widespread problem. A significant number of pediatric patients with ventilation tubes in their eardrum for ear infections incurred chronic perforations in their eardrum, or tympanic membrane. We did some research to find out how widespread this problem is. We found out that over 1 million surgeries each year in the US alone are performed to insert these ventilation tubes. And over 10% of these surgeries would result into chronic perforations. Also, there are over 700,000 perforations each year in the US alone from all other causes. These perforations can lead to infection, hearing loss, or even nerve and brain damage. The one and only treatment for this problem is surgery, in which the ENT surgeon puts the kid under anesthesia, makes an incision behind the ear to retract the ear and access the eardrum. Also, the cost of the surgery is up to $18,000 for surgery, with a success rate as low as 40%, as the surgeons have problems with the patch falling out of the perforation or recurring infections. Also, the patients may undergo hearing and taste loss, or even facial nerve paralysis. Jesse talked to two biomedical engineering graduate students, Elaine and I. We hypothesized that there must be a way to increase the success rate of the procedure, and addition of a tool to the surgeon's repertoire would be helpful. We also hypothesized that since all of these surgeries must take place in the hospital, our customer channel is the hospital. Our initial assumption was to make a gel to increase the success rate of the patches used to fill the perforation. The gel could start as a liquid, could be dropped onto the eardrum, throughout the ear canal, and could form a stiff gel upon UV irradiation right at the site of the perforation. Also, since the gel could start as a liquid, we could add antibiotics into it prior to gelation so that the cure gel could release antibiotics directly into the middle ear to fight with infections. To validate our assumptions, we surveyed 5 ENT surgeons, which then they stated that they would prefer a non-surgical procedure to be able to do the procedure in the clinic. We found out that the ENT surgeons usually work at a private practice, so they must rent out an operating room in order to be able to do the procedures in the hospital. So we pivoted based upon our customers' need to a standalone non-surgical treatment. Also, since we found out that the ENT surgeons would buy the product from us in order to be able to do the procedure in the clinic, we pivoted again and we changed our customer channel from the hospital to the ENT surgeons. In order to fully nail the customer's pain, we interviewed 2 ENT surgeons. We found out that they very much liked the idea of a non-surgical procedure, but they would prefer it did not use UV light because of all of its potential harmful effects. Also, they would prefer it did not use UV. They would be satisfied without time release of antibiotics into the middle ear because of drug resistance and longer regulatory pathway. So we pivoted again based upon our customer's need, and we chose material with inherent antibacterial properties so that they could actively fight with infection. Also, we chose blue light used to cure dental fillings in place of UV light. An unexpected pivot here was that one of the ENT surgeons we interviewed volunteered to work alongside this project with us. Now we could have direct feedback from our customer while we were developing our product. At this point, all of our hypotheses were directed toward the ENT surgeons, while we still needed to consider the actual end user, the patients with chronic perforations. We surveyed over 100 patients, potential patients and parents, and we found out that over 95% of patients would prefer a non-surgical alternative over an existing surgical procedure. At this point, we know that the customer wants our product, And by getting out of the building and directly interacting with our customer, we know what exactly to make. And all of this information to validate our business model has cost us $0 over a period of 4 weeks.
We assumed that we can manufacture the product ourselves if we have funding. First, we reached out to Tulane's Office of Technology Transfer. Tulane then puts us in touch with the New Orleans Bioinnovation Center, or NOBIC, so we can check out their resources and decide whether it is better to keep the project on campus or take it outside the university. Tulane offers us grant funding and patent protection if we stay on campus, and NOBIC offers their help developing our business even while we stay at Tulane. So we pivoted and brought on key partners, Tulane and NOBIC. Tulane gives us shared resources in exchange for intellectual property rights, and NOBIC helps us develop our business model. So once we got our grant funding from Tulane, we could validate our product by developing a prototype and testing it with an animal model. Both Kevin, the ENT surgeon, and Jesse, the medical student, are working alongside us throughout this prototype testing. The gel patch applied to the perforation acts as a scaffold to allow the cells to start growing across the perforation. As the cells are growing, they are actively degrading the material itself, so that the end result is that the patch is completely replaced with the new regrown tissue. Our prototype healed 80% of the chronic perforations in our animal model. This was double the success rate of the currently available surgical procedures. And we also validated that our product did not require surgery and could actively prevent infection. So, based upon our prototype testing, we know that we can manufacture the product ourselves and don't need to outsource this process. And the cost of goods sold for us will be about $15 per patch. But more importantly, we learned that Jesse, the medical student, could use our product. This meant that we can now add primary care physicians as a new customer channel. This is huge for us because now we can expand our customer base 20 times beyond just the ENT surgeons. So now that we validated that our product actually works, we can see how it addresses our customers' pain. For ENT surgeons, eardrum repair counts as one billable procedure. This procedure takes 1 hour to complete with surgery, whereas our product, which we are calling Perfix, can complete this procedure in less than 10 minutes for both ears. This means that the surgeon can now start transferring patients from the hospital to his own clinic and free up that hospital time to start taking on patients requiring more complex surgeries. And those more complex surgeries will have more billable procedures per surgery. So not only are we making the ENT surgeon more efficient, we're also helping him increase his profit margin. So for patients and insurance companies, the surgery costs $18,000, and we are offering our non-surgical treatment for 1/10 that cost. Not only are we a cost-effective alternative, but we are also eliminating all of the complications associated with surgery, such that the overall impact is that we are lowering medical costs and reducing the risk to the patient. So Kevin, the ENT surgeon who was working with us, presented the results of that prototype testing to his peers during a research conference at Louisiana State University. After the presentation, 10 out of the 12 ENT surgeons that we surveyed told us they wanted to use our product. But not only that, 3 of those ENTs approached us directly to tell us how excited they were about it, and they couldn't wait to start using it in their clinic. Additionally, we'll be presenting that research at national conferences later this year, and we'll be publishing it in peer-reviewed journals. So our product Perfix addresses a new, previously unmet market. We are offering the only non-surgical treatment for a widespread problem that affects millions of children across the globe every single year. As you can see, our competitors are Medtronic and Pfizer, but our competitors' products require hand trimming by the surgeon to fit the exact dimensions of the perforation site. This leads to lower treatment outcomes and longer surgery times, both of which are issues that our product Perfix resolves. So for the future, we're hiring PPD, a contract research organization, to assist us with FDA testing. Our product is a Class 2 medical device, and there are predicate devices we can reference to accelerate that process. We are also contacted by the military and NASA to see how our product can be adapted for their purposes, and these new customer channels will help us get early human clinical data ahead of our FDA approval. So the lean startup method maximized our efficiency in developing our prototype. We went through 3 virtual iterations with 20 ENT surgeons and based our product upon their feedback. We also and because of this, we only spent 75% of our grant, and our first prototype worked. We've also gotten additional feedback from other competitions and other investors and biotech firms from across the country. By using the business model canvas as a guide, we are able to validate assumptions about our customers' pain and how to make the best product to relieve that pain prior to incurring any expenses. Thank you.